Welcome to this walkthrough of Edexcel A-Level Mathematics Paper 3, that is Statistics and Mechanics of June 2018. This paper carries a total of 100 marks and is of 2 hours duration. In this walkthrough, we will attempt to finish this within the time allotted, and I will also take efforts to make the same level of presentation that is expected of the candidates in the actual exam. Question 1. Helen believes that the random variable C, representing cloud cover from the large data set, can be modeled by a discrete uniform distribution. Write down the probability distribution for C. Discrete uniform distribution means all the outcomes have equal probability. Also, the cloud cover in the large data set is measured using an integer called octas. Octas means 1/8 of the sky is covered by cloud. So there are 9 outcomes actually from 0 cloud cover, that means a very clear sky, to 1 part of the 8 parts covered by cloud, 2 parts covered by cloud, 3 parts covered by cloud, and so on, up to the entire sky being covered by clouds. So there are 1, 2, 3, 4, etc. up to 8. So there are 9 outcomes here. So in a tabular form, if we represent the uniform distribution, what we could write here is a table and we have been told that it should be C. C is this one, and the probability of C being a particular value is going to be this one. So if I divide this table into 8 equal parts and include 1 more to represent this 0 cover, so we can distribute it like this. And let us put the column heads. Okay, so this is going to be 0, 1, 2, 3, 4, 5, 6, 7, and 8. So there are 9 outcomes here, and each of these outcomes has the same probability. Therefore, this will be 1/9. This also 1/9. Each one will be 1/9. So this table is enough to represent the uniform discrete distribution for the outcomes. Part B. Using this model, find the probability that cloud cover is less than 50%. Cloud cover is less than 50% means you have to look at all the probabilities for less than 50% of this. If the cloud was fully covered, it would have been 8 out of 8. Therefore, if the cloud cover is 50%, it would have been half of it, that is 4/8. When the question says the probability is less than 50% means probability of C being less than 4. So looking at the table for probability less than 4, what are all applicable? 1, 2, 3, and 4. That means it's going to be 4/9. Part C. Helen used all the data from the large data set for Hearn in 2015 and found that the proportion of days with cloud cover of less than 50% was 0.315. Comment on the suitability of Helen's model in the light of this information. This is actually requiring a comment on the model. As per the actual findings, that probability was equal to 0.315. Then we should compare this with 4/9. It is less than 4/9, right? 4/9 is 4 out of 9 is greater than 0.315. 0.444. Therefore, we could say that as the actual probability is less than the one calculated using the model is not good. As the observed probability is less than the one calculated using the model, the model is not maybe we can capitalize this to catch the eye of the examiner, is not good. Part C. Suggest an appropriate refinement to Helen's model. Another 1 mark question here. You could say that the cloud cover will not remain constant for throughout the period and for different places. See, for example, large data set is applicable from May to October. For all those months and for different cities covered by it, the cloud cover cannot have the equal probability. So it will be different. Hence, the model could probably use a non-uniform distribution. That's what we should carry in our answer. So we could say the cloud cover will be different for different months for different places. Hence, a non-uniform distribution model will be more appropriate. That's it. Question 2. Tessa owns a small clothes shop in a seaside town. She records the weekly sales figures, W pounds, and the average weekly temperature, T degrees centigrade, for 8 weeks during the summer. The product moment correlation coefficient for these data is minus 0.915. Stating your hypothesis clearly and using a 5% level of significance, test whether or not the correlation between sales figures and average weekly temperature is negative. This is a hypothesis testing question, and as usual, we should document some important information from the question. First of all, the R, the product moment correlation coefficient, is minus 0.915. N, the elements in the number of samples is 8. Then we have the level of significance is given to be 5%. And then we need to write out the null hypothesis and the alternate hypothesis. For the null hypothesis, we always write rho is equal to 0. Remember, rho is the correlation coefficient for the entire population, and this R, the PMCC coefficient, which is the observed value from the question, it's for the sample. So when we write the null hypothesis, we will say rho is less than 0 because the question is asking us to test whether it is negative. The next step in the question is we need to find the critical value, CV. You will be given a table in which the level of significance will be there in the columns. See, for example, we have got 5% here, level of significance. So it will be 0.05. Look under this 0.05 and this rows will be the number in the sample. So we have got 8 in the sample, right? Therefore, this number is the critical value for these two combinations. And looking at the table, I get the critical value to be equal to 0.6215. I'll tell you a smart and easy method to compare the R value with the critical value and take a decision whether to accept or reject the null hypothesis. First, draw a line here, sort of a number line, and let's say this is the uppermost value of the critical value, 0.6215, and here minus 0.6215. 6215. If at all the R value falls inside this region, we will be accepting the null hypothesis. If it falls this side, that is if the R value is less than this, or if the R value is more than this, then it will be in the rejection region. Say reject, reject. Now the R value in this question is minus 0.915. It actually falls on this side of minus 0.6215, this side. That means it is less than minus 0.6215. So we write as R is equal to minus 0.915 is less than minus 0.6215. There is sufficient evidence. Always qualify your answer with sufficient evidence. There is sufficient evidence to reject HO. We also need to interpret this, so we will write there is sufficient evidence of negative correlation between the W pounds, okay, and T degrees centigrade. Part B suggests a possible reason for this correlation. The question here compares the weekly sales figures with the temperature during summer. So why would there be a negative correlation? You could write any plausible reason why there could be a negative correlation. For example, you could say that when the temperature reaches high temperature levels, these people do not do shopping. As temperature increases, people do less of shopping. Part C. Tessa suggests that a linear regression model could be used to model these data. State giving a reason whether or not the correlation coefficient is consistent with Tessa's suggestion. The product moment correlation coefficient actually measures how closely the data points fall around a straight line. If R is -1 or close to it, it means it's a line sloping down. And if R is close to +1, it represents a straight line going up. On a scatter graph, if we represent it, it will be like this. -1 R would mean a straight line going down like this. A +1 R would mean a line going up like this. And if it is 0, it means there is no correlation. The points are all happening everywhere. So here what we would write is this model is consistent with the results, or Tessa's argument. We could say as R is close to, it was -0.915, wasn't it? So it's close to -1. So as R is close to -1, it is consistent with the negative correlation, with a linear relationship showing negative correlation. Part D. State giving a reason which variable would be the explanatory variable. In regression analysis, that variable which affects another variable is called the explanatory variable. And the variable that gets affected is called the response variable. Here the weekly average temperature affects the sales, and therefore temperature is the explanatory variable. So we could write temperature is the explanatory variable. As the sales is affected by temperature. Tessa calculated the linear regression equation as W equals 10,755 take away 171 times T. Give an interpretation of the gradient of this regression equation. So here you can see minus 171 T. In that, minus 171 is the gradient of the line. Therefore, that is the rate at which the weekly sales will go down. For every degree temperature rise. So we could say every 1 degree centigrade rise in temperature leads to a decrease in weekly sales by pounds 171. Okay, that is question 2. Question 3. In an experiment, a group of children each repeatedly throw a dart at a target. For each child, the random variable h represents the number of times the dart hits the target in the first 10 throws. Peter models h as binomial distribution with 10, 0.1. State 2 assumptions Peter needs to make to use her model. So we know in a binomial distribution, there are 4 assumptions that should be satisfied so that it can be fitted in a binomial distribution. The first thing is that n should be a fixed limited number. It should not be like 2,000, 50,000, etc. And secondly, the outcomes, the number of outcomes should be binary. That is, yes or no outcomes. Okay. Third assumption is that the probability of something happening there is consistent for all the outcomes. And finally, each event should be independent of each other. So we could select any 2 relevant assumptions from here, which will be useful for this situation. So you could say the probability of the dart hitting the target for each child is a constant. The outcome of each throw is independent. So the probability is constant and the outcome of each throw is independent of each other. Part B. Using Peter's model, find probability of h greater than or equal to 4. So let's write the distribution model here. H follows binomial distribution. 10 trials, probability 0.1. We want to find out the probability of h being greater than or equal to 4. If your calculator allows you to calculate probability of h greater than or equal to 4 directly, you could do that. Or in some calculators you may have to do, this is probability of 1 minus the probability of h being less than or equal to 3. Okay, so you could do that way also. I'm going to use my computer calculator, which can let me calculate straight away greater than or equal to. So n is number 10 here, and the probability is 0.10, and I need to include 4 and above. That means I should put 3 here, so that anything above 3 is calculated. And the answer here is 0.0128. 0.0128. Part C. For each child, the random variable f represents the number of the throw on which the dot first hits the target. Using Peta's assumptions about this experiment, find probability of f equal to 5. Here, f is equal to 5 would mean the first 4 attempts by the child will result in a failure, and the 5th attempt will result in a success. Hence, we could write probability of f being equal to 5 is equal to failure is 1 minus p to the power of 4 times probability of success. That is equal to, we know the probability of success is 0.1 here. So 1 minus p will be 0.9. That happens 4 times. And then the success happens. That is 0.1. That is equal to 0.06561. Next part of the question. Thomas assumes that in this experiment, no child will need more than 10 throws for the dart to hit the target for the first time. He models probability of f is equal to n as probability of f is equal to n equals 0.01 plus n minus 1 times alpha, where alpha is a constant. Find the value of alpha. Here n would mean the number of attempts by the child when the dart will be hitting the target for the first time, and that will be within the 10 attempts. So let us write Thomas's model here. He says probability of f being equal to small n is equal to 0.01 plus n minus 1 times some alpha. Let us also put this table of probabilities as per this model. So here f is equal to n, and this represents probability of f being equal to that value of n. N represents the throw in which the dart first hits the target. So first hits the target for the first time on the first throw, second throw, third throw, fourth one, fifth one, sixth, seventh, eighth, ninth, and the 10th one. As per the model, the probability of the dart hitting the target on the first throw itself is 0.01 plus n minus 1, which is 1 minus 1, that is 0 times alpha, so 0. Okay. For the second one, it will be 0.01 plus 2 minus 1 alpha, that is 1 alpha, and so on. 0.01 plus 3 minus 1 will be 2 alpha. So it will be like an arithmetic progression. You can see that 3 alpha here, 0.01 plus 4 alpha. Let's complete this out. 5 alpha, 0.01 plus 6 alpha, 0.01 plus 8 minus 1, 7 alpha, 0.01 plus 9 minus 1, 8 alpha, 0.01 plus 9 alpha. We know that sum of all probabilities should be equal to 1. Is equal to 1. And this follows an arithmetic series with the first term a is equal to 0.01, the common difference D is equal to alpha and the number of terms is equal to 10. And there are two formulae, one of which you can use for finding the sum of an arithmetic series, that is Sn is equal to n over 2 bracket 2a plus n minus 1 times d. That's one equation. The second one, an easier one, is n over 2 bracket the first term a plus the last term. That's it. I'm going to use this formula, but you can also use the first formula and check for yourself whether you get the same result. Since this sum should be equal to 1, I would say 1 equal to 10 over 2 bracket the first term is what? 0.01. The last term is 0.01 plus 9 alpha. That is 1 is equal to 5 bracket 0.02 plus 9 alpha. Therefore, 1 over 5 is equal to 0.02 plus 9 alpha, leading to this 1 over 5 is what? 0.2 minus 0.02 is equal to 9 alpha. Therefore, 1 alpha is equal to 0.18 divided by 9 is equal to 0.02. Hence, the value of alpha is equal to 0.02. Part E. Using Thomas model, find the probability of f being equal to 5. Probability of f being equal to 5 is just this probability. So E, probability of f being is equal to 5 is 0.01 plus 4 times the alpha value 0.02 is equal to 0.01 plus 0.08 equal to 0.09. Part F. Explain how Peters and Thomas models differ in describing the probability that a dart hits the target in this experiment. Peter had modeled the probability of hitting the target using binomial distribution model, and therefore the probability was assumed to be constant. But as per Thomas model, the probability of f is equal to n is equal to 0.01 plus n minus 1 times alpha. This means, as per Thomas' model, the probability increases each attempt. So we could write in comparison, as per Peters' model, the probability of the dart hitting the target is constant. Means it doesn't change. As per Thomas model, the probability increases with each attempt. Question 4. Charlie is studying the time it takes members of his company to travel to the office. He stands by the door to the office from 8:40 to 8:50 one morning and asks workers as they arrive how long their journey was. State the sampling method that Charlie used. Standing at the door for a period of time and interviewing the people who come along at that time is a good example of convenience or opportunity sampling. So convenience / opportunity sampling. Part B. State and briefly describe an alternative method of non-random sampling Charlie could have used to obtain a sample of 40 workers. So the earlier method mentioned was a non-random sampling method. The question is now asking, can you state another method in which a sample of 40 workers could be obtained? Well, they could use quota sampling, which is also a non-random sampling method. Example, take 4 people every 10 minutes or 8 people every 5 minutes until they get a sample of 40 workers. Part C. Taruni decided to ask every member of the company the time X minutes it takes them to travel to the office. State the data selection process that Taruni used. Well, the key phrase here is ask every member of the company. Asking every member of the company is census. Part D. Taruni's results are summarized by the box plot and summary statistics below. You can see 2 outliers there. The box plot diagram is given. For the statistics of n, the frequency 95 is given, sigma x is given, sigma x square is given. Write down the interquartile range for these data. Well, the interquartile range means Q3 minus Q1. Going by the scale of this box plot diagram, each division here represents 2. So this is 52, 54, 56, 58. So Q3 is 58 and Q1 is 4 short of 30, which is equal to 26. Therefore, interquartile range IQR is equal to Q3 minus Q1 is equal to 58 minus 26 equals 32 minutes. Part E. Calculate the mean and the standard deviation for these data. So mean is nothing but sigma x divided by n, the total frequency. So mean is equal to sigma x over sigma f, or the total number. Here it is given as 4133 divided by 95. So the mean comes to 43.505. So that is mean. Standard deviation is equal to, put a big square root sign. It is mean of the squares minus square of the mean. So standard deviation is equal to square root of, let's look at the squares here. The sum of the squares is 202,294. 202,294 divided by the total frequency is 95 minus square of the mean. We already calculated the mean here. We just need to square it here. 43.505 squared is equal to 15.38588, etc. But that's fine. Part F. State, giving a reason, whether you would recommend using the mean and standard deviation or the median and interquartile range to describe these data. Looking at the box plot diagram, you can see there are 2 large outliers, and therefore if taken into account, they will affect the mean and they can also affect the standard deviation, but they are unlikely to change the median or the interquartile range. So we could write, as there are outliers which can affect the mean and standard deviation, it is better to use median and interquartile range to describe the data. Last part of the question. Rana and David both work for the company and have both moved house since Tharuni collected her data. Rana's journey to work has changed from 75 minutes to 35 minutes, and David's journey to work has changed from 60 minutes to 33 minutes. Tharuni drew her box plot again and only had to change 2 values. Explain which 2 values Tharuni must have changed and whether each of these values has increased or decreased. In a box plot diagram, these are percentiles. This is Q1, 25 percentile of the data points. This is Q2 or median, which is 50% of the data points, and this is Q3, which is 75% of the data points. So what has changed? A data point of 75 minutes, which is somewhere here, which is outside the Q3, has moved to 35 minutes, which is inside the box and even before the median, the current median. So 35 minutes is somewhere here. All right. Similarly, another data point of 60 minutes, which is also outside the Q3. Q3 is here, whereas 60 is here. So that has also moved inside the box and it has come to 33 minutes here. That means 2 new data values have come outside of the box beyond the Q3, inside the box to between Q1 and Q2. Therefore, 2 values that will change in the new box plot diagram will be the Q2 and obviously the Q3. As 75 minutes and 60 minutes that are currently, we could say that are outside / above the current Q3. Current Q3 have moved in, into the box between Q1 and Q2. Then we will say what will change. Q2 and Q3 data values will change. Well, that's not enough. We should also say whether they will decrease or increase. To understand this, just look at what has happened here. More values have come in inside this region between Q1 and Q2 because Q2 represents 50% of the values and Q3 represents 75% of the values. The number of values having increased inside would mean Q2 will move to the left a bit and Q3 will also move to the left a bit. That means the new Q2 and new Q3 values will be lower than the current values. Both Q2 and Q3 will decrease in the new box plot. That's it. Question 5. The lifetime L hours of a battery has a normal distribution with mean 18 hours and standard deviation 4 hours. Alice's calculator requires 4 batteries and will stop working when any one battery reaches the end of its lifetime. Question A. Find the probability that a randomly selected battery will last for longer than 16 hours. So let's write the model of the distribution. L follows normal distribution with 18 and standard deviation. How much was it? 4 hours. So 4 square. The question asks for the probability that a randomly selected battery will last for more than 16 hours. That means probability of L being greater than 16 hours. So it's not equal to, it's just greater than 16 hours. So let's go to the normal distribution calculator. So we put mean is equal to 18, standard deviation 4. And since it doesn't include 16 hours, I should be putting above 16, right? And that is 0.6915. So 0.6915. Part B. At the start of her exams, Alice put 4 new batteries in her calculator. She has used her calculator for 16 hours already, but has another 4 hours of exams to sit. Find the probability that her calculator will not stop working for Alice's remaining exams. Writing this using the probability conditions, this is actually finding out the probability that a battery will last for more than 20 hours, given that it has already lasted for more than 16 hours. So let us write this conditional probability as probability of L being greater than 20, given that L is already greater than 16. The formula for probability conditional one is like this. Probability of A given B is equal to probability of A intersection B divided by probability of B. So we can use the same rule here. This is equal to probability of L greater than 20 intersecting with L greater than 16 over the second one in the denominator, probability of L greater than 16. This part has been confusing to many students. Therefore, let me explain this to you. This intersection actually means both these criteria have to be satisfied. That means L has to be greater than 16 and L has to be greater than 20. What is that eventuality? So let's look at what are the examples of L being greater than 16. It should be 17, 18, 19, 20, and so on. And what is greater than 20? Let me put 21 and 22 also here. All these are satisfying the condition that L is greater than 16. L is greater than 20 actually starts from 21, 22, 23, etc. Now, when we say both these conditions have to be met, because the intersection means that, so we have only that eventuality where L is greater than 20, because 17, 18, 19, 20 will not satisfy the second condition. So the numerator actually simplifies to L greater than 20. Therefore, this equation simplifies to probability of L greater than 20 upon probability of L greater than 16, which we have already calculated. So let's put these values here. Let's calculate what is the probability of L greater than 20 using the normal distribution calculator. Mean 18 and standard deviation 4 continue, and above 20. That gives us 0.3085. 0.30. Sorry for the glitch there. 0.3085 upon We have already calculated probability of L greater than 16, which is 0.6915. 0.6915, and that is equal to, that gives 0.44613 and so on. This is still not over. This is the probability that one randomly selected battery will last for more than 20 hours. But Alice's exam requires 4 batteries in her calculator, and all the 4 batteries should work for more than 20 hours so that she will be able to complete the exam. That means the probability that she will be able to complete the exam will be 0.44613 to the power of 4. That is equal to 0.0396, 1 and so on. Writing this to 4 decimal places, part B will be 0.0396. Part C. Alice only has 2 new batteries, so after the first 16 hours of her exams, although her calculator is still working, she randomly selects 2 of the batteries from her calculator and replaces these with 2 new batteries. Show that the probability that her calculator will not stop working for the remainder of her exams is 0.199 to 3 significant figures. This is an interesting situation here. In order that Alice completes her 4 hours of exams, the 2 new batteries should last for more than 4 hours. That is, probability of L greater than 4 for 2 batteries. So it needs to be squared. Okay. These have to work with 2 old batteries for which the probability of lasting more than 20 hours, given that they have already lasted for more than 16 hours, should be calculated by squaring that also. Putting this in our normal distribution calculator, so mean 18 hours, standard deviation 4 hours, above just 4 hours. That will give us 0.9998. 0.9998 squared times. This probability we have already calculated earlier, that is lasting for more than 20 hours, given that it has already lasted for 16 hours for one battery is 0.44613. 0.44613, and this has also to be squared. So this works out to 0.19895. Okay, and then we can confirm with the other earlier answers to 4 decimal places. We could write this as 0.1990. The question wants us to show that this probability is 0.199 to 3 significant figures. So this is fine. So we have shown that now. Today, after her exams, Alice believed that the lifetime of the batteries was more than 18 hours. She took a random sample of 20 of these batteries and found that their mean lifetime was 19.2 hours. Stating your hypothesis clearly and using a 5% level of significance, test Alice's belief. This is a hypothesis testing question using sample mean of a normal distribution. There are a few aspects to this question where the answer could go wrong, and that's why there are 5 marks to this question. To break down the question, Alice took a sample of 20 and she found that the mean lifetime was 19.2 hours. She believes that the lifetime of the batteries was more than 18 hours. First and foremost, a little bit of tutorial on the normal distribution sample mean. If a random variable x follows normal distribution with mu and sigma square, then the sample mean, let's mark it as x bar. This sample mean also follows normal distribution with the same mu, but the variance becomes sigma square divided by the sample size n. Therefore, we need to use these parameters to test Alice's claim. Let L represent a variable representing the lifetime of the battery. Let L be the lifetime in hours of a battery. Then L follows normal distribution with mu 18 and sigma square is 4 square. The sample size n is equal to 20. The observed value of mu, observed value of mean of the sample is equal to 19.2 hours. Therefore, the sample mean L bar will follow normal distribution. As per this formula, we will write 18 here, the original mu, and sigma square will be 4 square upon n, which is 20. This part in the formula is the variance, right? But to put in the calculator, we need sigma, and therefore we can say sigma is equal to square root of this variance, 4 square over 20. That is equal to, putting this into the calculator, we get 0.8944 to 4 decimal places. Hence, we could write the L bar, that is the sample mean, follows normal distribution 18, 0.8944 square. Keep this ready because this is what we have to put into the calculator. Now, to document all the steps required for the hypothesis testing, we should first write the null hypothesis and the alternate hypothesis. The null hypothesis is mu is equal to 18 hours. And the alternate hypothesis is she's suspecting that this mu has gone beyond 18. That is, mu is more than 18. The next statement required is assuming HO to be true. What's the probability of the sample mean being greater than 19.2, the observed value? Now we will put this into the normal distribution calculator and find the probability. This is the normal distribution calculator. So we'll put mean is equal to 18. Standard deviation was the value that we calculated, 0.8944. And we are testing what is the probability that this is greater than 19.2. And that gives us the probability of 0.0898. 0.0898. We have been given alpha is equal to 5%. That is equal to 0.05 because it's a one-tailed test. We will now compare the calculated probability with the level of significance. I would recommend you to make a clear presentation like this. Put a rectangle and put the level of significance here 0.05 and put the observed value probability as 0.0898 and determine which one is greater. 0.0898 is obviously greater than this, so put this inequality here. What this means is, as per the null hypothesis scheme of things, getting a 19.2 hours as mean of the sample is within the probability, so that is not an outlier. Therefore, null hypothesis need not be rejected. To narrate our conclusion, we write as 0.0898 is greater than 0.05, there is insufficient evidence. And underline that so that it will be categorical. Insufficient evidence to reject HO. That means we are not going to reject HO. To interpret this contextually, we also write that there is no evidence that the lifetime of batteries has increased more than 18 hours. That's it. Section B, mechanics. So read this general instruction. Question 6. At time t seconds, where t is greater than or equal to 0, a particle P moves in the xy plane in such a way that its velocity v meters per second is given by the expression v equals t to the power of minus half I minus 4tj. When t is equal to 1, P is at point A, and when t is equal to 4, P is at the point B. Find the exact distance AB. So in short, we have been given the velocity function and we have been asked to find the distance. So our strategy should be, we integrate velocity function with respect to t, and that will give us the displacement function. In that displacement function, we put t is equal to 1 and t is equal to 4, which will give us the 2 points or the positions of this particle at t is equal to 1 and t is equal to 4. If we find the difference between those two positions, we will be able to get the displacement between them. Then if we find the absolute value slash the modulus of that displacement, we will be able to get the exact distance. So we write r is equal to integral of v with respect to time. So here we write integral of v dt is equal to t to the power of minus half plus 1 over minus half plus 1 I minus 4 t to the power of 2 over 2 j, and then plus c. This simplifies to t to the power of half over half I minus 2t square j plus c. That is, dividing by half is actually multiplying by 2, so it becomes 2 to the power of half minus 2t square j plus c with I here. Okay. At t is equal to 1, therefore r is equal to 2I minus 2j plus c, and at t is equal to 4, r is equal to 2 times 4 to the power of half, that is 4I, minus 2 times 4 square, that is 2 times 16, 32j plus c. Let's say this is position 1 and this is position 2. Therefore, displacement is equal to position 2 minus position 1, which is 4I minus 2I is 2I, then minus 32j minus 2j is minus 32 minus of minus 2j, which is minus 30j, and the c disappears. Therefore, distance is equal to square root of 2 square plus minus 30 square is equal to square root of 4 plus 900 equal to square root of 904, which simplifies to, putting this into the calculator, we get 2 square root of 226. Since the unit is given as meters, we could write meters. That's it. Question 7. A wooden crate of mass 20 kg is pulled in a straight line along a rough horizontal floor using a handle attached to the crate. The handle is inclined at an angle alpha to the floor as shown in figure 1, where tan alpha is equal to 3/4. The tension in the handle is 40 newtons. The coefficient of friction between the crate and the floor is 0.14. The crate is modeled as a particle and the handle is modeled as a light rod. Using the model, find the acceleration of the crate. I have redrawn the diagram here. Let me also write the relevant information. Coefficient of friction mu is given to be 0.14. Tan alpha is given to be 3/4. And the question is, acceleration is equal to what? So first of all, draw a right angle triangle. Let us say this is angle alpha. Okay. Tan alpha is 3/4 means opposite side over adjacent side. This is 3/4. Therefore, automatically we can calculate the hypotenuse. 9 plus 16, 25 square rooted is 25 is equal to 5. Therefore, sine alpha will be equal to 3/5. Cos alpha is equal to 4/5. Let us now label the remaining forces on this diagram. So mass is 20 kg, therefore the weight will be 20 times the acceleration due to gravity. There is a friction here. This is F, and there will be R here. Right. So the strategy for this question is, using all the forces and the mass given here, we will write the equation F is equal to ma and find out A from this. Here a common student error is taking R equal to 20g. We should appreciate that R is supported by a vertical component of this 40 newtons force. So let's also calculate what is this upward component of this 40 newtons here. So in order to find this out, we have to use the sine alpha. You can say that sine alpha is equal to opposite over hypotenuse 3/5. Okay, right. The vertical component of this 40 newtons force is 40 sine alpha is equal to 40 times 3/5. Therefore, R plus 40 times 3/5 equals 20g. Hence, R equals 20g minus, this is 8 times 3, 24. That gives us 172 newtons. Writing out F is equal to ma now, F will be 40 cos alpha minus the frictional force. Therefore, 40 cos alpha minus the frictional force is mu times the R, that is 0.14, which is the mu, times the R that we calculated here, is equal to mass 20 times the acceleration A. Cos alpha being 4/5, we could write here 40 times 4/5 minus 0.14 times 172. The whole divided by 20 is equal to A. Putting into the calculator, we get 0.396 meters per second. Second square acceleration. Part B. The crate is now pushed along the same floor using the handle. The handle is again inclined at the same angle alpha to the floor, and the thrust in the handle is 40 newtons as shown in the figure 2 below. Explain briefly why the acceleration of the crate would now be less than the acceleration of the crate found in part A. Pushing the crate instead of pulling changes the R value. Here everything else remains the same, but pushing will change the direction of the vertical component of this 40 newtons. So what happens here is R will be equal to 40 sine alpha plus 20g. That is, r is equal to 40 times 3 over 5 plus 20 times 9.8, and putting into the calculator we get this is 220 newtons. Earlier it was 172 newtons. So what we need to write here is, as pushing increases, the value of R from 172 newtons to 220 newtons, the acceleration will be lower. Question 8. In this question, I and j are horizontal unit vectors due east and due north respectively, and position vectors are given relative to the fixed point O. A particle P moves with constant acceleration. At time t is equal to 0, the particle is at O and is moving with velocity 2I minus 3j meters per second, and at time t is equal to 2 seconds, P is at the point A with position vector 7I minus 10j meters. Show that the magnitude of the acceleration of P is 2.5 meters per second square. So this is a show that question, and the advantage of this kind of questions is at the end of the answer you will be able to know whether your answer is correct or not. The key word in this question is constant acceleration. Therefore, you can use Suvat equations. Since we have been given the velocity and the time gap as well as the new position, we can calculate using s is equal to ut plus half at square, the new position, and equate that with 7I minus 10j, and using that we can solve for a. So first let's write all the bits of information given in the question. At t is equal to 0, r is at O, okay, and at t is equal to 2 seconds, the position is what? R is equal to at point A, where s is equal to 7I minus 10j meters from the origin. And when t is equal to 0, r is at O, and velocity is given to be equal to 2I minus 3j meters per second. Okay. Now let's use s is equal to ut plus half at square. Substituting the values, u is 2I minus 3j, time is 2, plus half, a we don't know, time is 2 square, and that should be equal to 7I minus 10j. Therefore, simplifying, 4I minus 6j plus 2a is equal to 7I minus 10j. Therefore, 2a equals 7I minus 4I, 3I, minus 10j minus of minus 6j is 4j, and therefore a equals 3 over 2I minus 2j. We need to find the magnitude as per the question. So magnitude of a equals square root of 3 over 2 squared plus minus 2 squared equals square root of 9 over 4 plus 4, and simplifying we get square root of 25 over 4, which is equal to 5 over 2, which is equal to 2.5 meters per second square as required in the question. Final part of the question. At the instant when P leaves the point A, the acceleration of P changes so that P now moves with constant acceleration 4I plus 8.8 j meters per second square. At the instant when P reaches the point B, the direction of motion of P is northeast. Find the time it takes for P to travel from A to B. To comprehend the question, let us represent it diagrammatically. So from position O, the particle moves to point A, and from there the particle moves to point B. At O, t is equal to 0, and velocity is given as 2I minus 3j. At point A, t is equal to 2 seconds. Velocity we do not know. In between origin and the A, we found out that the acceleration is equal to 3 over 2I minus 2j meters per second square. Okay, at B, we have been told that the new acceleration is 4I plus 8.8j, and we need to find the time it takes for P to travel from A to B. We need to find the time at B. We also need to find the velocity at B, but we have been told that the direction of motion is northeast. And the acceleration when it leaves A is 4I plus 8.8j. 4I plus 8.8j. This diagram gives us a good idea now. Using the starting velocity 2I minus 3j, it's this acceleration as well as the time is equal to 2 seconds, we shall be able to find velocity at A. Using that velocity and the subsequent acceleration, we can find out the new velocity when it reaches B. And using the fact that the velocity is northeast, we will be able to solve for t. So let's write v is equal to u plus at, that is, the velocity at A is equal to the starting velocity 2I minus 3j, time is 2. So I need to write u plus at. Acceleration is what? 3 over 2I minus 2j times time is 2. Simplifying, velocity at A equals 2I minus 3j, adding 2 times 3 over 2 is 3I, minus 2 times 2 is 4j. This gives us 5I minus 7j meters per second. That is velocity at A. Therefore, velocity at B is equal to, again, u plus at, 5I minus 7j plus acceleration is the new one, 4I plus 8.8j times t. Adding all the I components and the j components, we get 5 plus 4t I plus minus 7 plus 8.8 tj. Perfect. Now we need to use the fact that at B, the velocity direction is northeast. Northeast means, so it is perfectly like y is equal to x. This is north, this is east. Northeast means on this line, every point will have I is equal to j. I, j both will be equal. If it is one I here, one j here, that is y is equal to x, sort of. Therefore, we can write at B, velocity direction is northeast. Hence, I component of the velocity will be equal to j component. Which means what here? We have got 5 plus 4t should be equal to minus 7 plus 8.8t. Therefore, 12 is equal to 4.8t, leading to t is equal to 12 over 4.8. That is equal to, putting into the calculator, we get 2.5 seconds. Perfect. That's the time of reaching B. Question 9. This is a long-worded question. A plank AB of mass m and length 2a rests with its end A against a rough vertical wall. Rough means there is friction there. The plank is held in a horizontal position by a rope. One end of the rope is attached to the plank at B, and the other end is attached to the wall at the point C, which is vertically above A. Right. A small block of mass 3m is placed on the plank at the point P, where AP equals x. The plank is in equilibrium in a vertical plane, which is perpendicular to the wall. The angle between the rope and the plank is alpha, where tan alpha equals 3 over 4, as shown in the figure 3. The plank is modeled as a uniform rod, the block is modeled as a particle, and the rope is modeled as a light inextensible string. Using the model, show that the tension in the rope is 5 mg 3x plus a over 6a, 3 marks. I have captured the diagram in the question here. Let us now label the remaining parts. It's a uniform rod, therefore its weight will be acting directly from the center point, which is 1a from A to this place, and its mass was given to be m, so the weight is mg. And P has got a mass of 3m, therefore it is 3 mg. Fine. Now, the vertical component, there is a tension here along the rope. Okay, we may have to find the vertical component here. So let me draw here this component. We will find out what is that. Now it must be T sine alpha. Okay, we have been told that tan alpha is equal to 3/4. Therefore, if we draw the right angle triangle, we will see that sine alpha is equal to 3 over 5 and cos alpha is equal to 4 over 5. And we have to find T is equal to what. Okay, so the best thing to do here is take moments about A. Taking moments about A. Okay, so what will be the clockwise forces? The clockwise forces at A are because of this mg and this 3 mg. So moment is always force times perpendicular distance. Therefore, mg times its perpendicular distance from A is A plus 3 mg times its perpendicular distance from A is x. All right. Now let's also work out the anti-clockwise forces. So the anti-clockwise force, there is no upward force except this T sine alpha, and therefore we need to multiply T sine alpha by the perpendicular distance from A, which is 2A. Therefore, it is equal to T sine alpha times 2A. Since sine alpha is equal to 3 over 5, it is T times 3 over 5 times 2A. As the rod is kept in equilibrium, these forces should be equal. Therefore, T times 6A over 5, T times 6A over 5 equals mg bracket A plus 3x. So we need to find out T from here. So T equals mg bracket a plus 3x times 5 over 6a. That's equal to 5 mg bracket a plus 3x all over 6a, which is as per the question. So we have shown that T is equal to the requisite expression. Part B. The magnitude of the horizontal component of the force exerted on the plank at A by the wall is 2 mg. Find x in terms of A. The horizontal component of force exerted by the wall on the plank at A is equal to 2 mg, means there is a force 2 mg from the wall in this direction. You can take it as the frictional force from the wall on the plank. And in that case, since the plank is in equilibrium, this 2 mg must be compensated by a horizontal component of the force because of this tension in the leftward direction. So we could say 2 mg from the wall is equal to the horizontal component of the tension, which is T times cos alpha. That is 2 mg. Let us now substitute the value of T from what we have found out from part A. 5 mg bracket a plus 3x all over 6a times cos alpha, which is 4 over 5, which is 20. We can cancel the mg from both sides. Therefore, 2 equals 4 times 5, 20 bracket a plus 3x all over 5 times 6, 30a. That is 2 equals 2 bracket a plus 3x over 3a, which means 2 times 3a over 2 is equal to a plus 3x. Hence, this 2 and this 2 cancelled. 3a minus 1a is 2a is equal to 3x, which means x is equal to 2/3a. Part C. The force exerted on the plank at A by the wall acts in a direction which makes an angle beta with the horizontal. Find the value of tan beta. We already know that at point A on the wall, the horizontal component of force exerted by the wall on the plank is 2 mg. Imagine this is the 2 mg, the horizontal component along the x-axis. Now, to find the tan of the angle, we need to find the y component. That y component may be the net of the upward and the downward forces. So we could say, let y be the net vertical component. Of the force exerted by the wall on the plank. Now that means y will be equal to the downward force take away the upward force. Okay. Now what is the downward force? If you look at this, there is this weight mg and 3 mg doing the downward and t sine alpha going upward. That is equal to 3 mg plus 1 mg minus the upward was t sine alpha. Let us now substitute with the values known to us. So y component is equal to 4 mg minus the t was calculated by us as 5 mg bracket a plus 3x all over 6a, right? Times sine alpha is 3 over 5. Also we know that x is equal to 2/3 a. Now we will cancel this 3 with this 6 and put 2 here, this 5 and this 5, and we will also substitute x is equal to 2/3 a in this spot. So we will be writing y is equal to 4 mg minus mg bracket a plus 3 times 2/3 a all over, there is a 2a remaining over here. Now that is equal to 4 mg minus mg bracket 3 and this 3 cancel, therefore 2a plus 1a, 3a over 2a, that is equal to 4 mg minus 3 over 2 mg, and that is 4 minus 1.5, that is 2.5 mg. Therefore y is equal to 2.5 mg. We already know that x is equal to 2 mg. Therefore to find the tan beta is equal to y over x is equal to 2.5 mg over 2 mg is equal to 1.25. Last part of the question. The rope will break if the tension in it exceeds 5 mg. Explain how this will restrict the possible positions of P. You must justify your answer carefully. For the rope not to break, T should be less than or equal to 5 mg. That means we know already the value of T, that is 5 mg bracket 3x plus 1a all over 6a, and this should be less than or equal to 5 mg. Please do not substitute x is equal to 2/3 a here, because the position of P is what we are calculating, so that the rope will not break. So we need to figure out what will be the possible positions of P, which is x. Now cancelling this 5 mg from both sides, we get 3x plus a over 6a is less than or equal to 1, which means 3x plus a should be less than or equal to 6a. Hence 3x should be less than or equal to 5a, which leads to x should be less than or equal to 5 over 3 a. This actually means the rope should not break, means P should be within a distance of 5/3 a from point A. So let's write that. For the rope not to break, P should be within a distance of 5 over 3 a from capital A. Question 10. This is a projectile question. A boy throws a ball at a target. At the instant when the ball leaves the boy's hand at the point A, the ball is 2 meters above the horizontal ground and is moving with speed u at an angle alpha above the horizontal. In the subsequent motion, the highest point reached by the ball is 3 meters above the ground. The target is modeled as being the point T, as shown in figure 4. The ball is modeled as a particle moving freely under gravity. Using the model, show that u square equals 2g over sine square alpha. I have captured the diagram given in the question here. In projectile questions, we should resolve the velocity into horizontal and vertical components. This is the vertical component, this is the horizontal component. So if alpha is the angle, the vertical component will be u sine alpha and the horizontal component will be u cos alpha. The question says that the highest point reached by the ball is 3 meters. Therefore, at that highest point, what will be the displacement? S equals 3 minus 2 is equal to 1 meter. Also at the highest point, the vertical component of the velocity, let's call it as Vy, will be equal to 0 because it's going to turn around there, right? And then what's the acceleration due to gravity? Let's take anything that goes up as positive and anything that comes down as negative. So it is minus 9.8. Therefore, using the formula V square is equal to U square plus 2AS, we can say V, the vertical component, is 0 at the highest point, and U square is the initial vertical component of the velocity, that is U sine alpha. U sine alpha, let's put that as a square there, plus 2 bracket minus 9.8 times the displacement at that highest point is 1. Simplifying this, 0 is equal to U square sine square alpha minus, since the question wants us to retain the g instead of 9.8, let's write minus 2g. Okay. This means U square sine square alpha is equal to 2g, which leads to U square is equal to 2g upon sine square alpha, which is what the question wanted us to show. Part B. The point T is at a horizontal distance of 20 meters from A and is at a height of 0.75 meters above the ground. The ball reaches T without hitting the ground. Find the size of the angle alpha. The question gives us both the horizontal as well as the vertical displacement at the target T. And at the target T, the time taken will be the same because Tx will be equal to Ty. So using the two Sivat equations and substituting for the T value, we may be able to solve for alpha from there. Let's see. The horizontal displacement, let us call it as Sx, is equal to 20 meters. And the formula for the horizontal displacement is Sx is equal to ut plus half at square. Therefore, 20 is equal to, the horizontal component of the velocity was u cos alpha, and the t is there, plus half at square will be 0 because the horizontal acceleration is 0 after it is projected. Therefore, t equals 20 divided by u cos alpha. Let's park it there. At the target point at T, the vertical displacement, let's call it as Sy, will be equal to 2 meters minus 0.75 meters, or the other way around, because whatever is coming down, we are going to take it as negative. So let's put it as 0.75 minus 2 is equal to minus 1.25 meters. We also know that the vertical displacement has this formula. Sy is equal to u sin alpha ut, sin alpha t, plus half at square. That is, a is minus 9.8 times t square. Therefore, minus 1.25 meters is equal to u sin alpha. Instead of t, I can use 20 over u cos alpha minus 9.8 divided by 2 becomes 4.9, and again t square becomes 20 over u cos alpha square. Simplifying this further, we get minus 1.25 is equal to u and u cancel. Sin alpha over cos alpha become tan alpha. So 20 tan alpha minus 4.9 times 400 over u square cos square alpha. From the earlier part of the question, we already know that u square is equal to 2g over sin square alpha, which we can put inside here. Therefore, this is minus 1.25 equals 20 tan alpha, no change there, minus 4.9 times 400, putting in the calculator we get 1960 times 1 over u square can be written as 2g over sin square alpha times this cos square alpha is there. Rewriting this, minus 1.25 is equal to 20 tan alpha minus 1960 times. The denominator of the denominator will come to the numerator. That is sin square alpha over cos square alpha times, now I got the 2g there, so 1 over 2 times 9.8. Simplifying this further, minus 1.25 equals 20 tan alpha minus 1960 here divided by 2 times 9.8 is 19.6 times sin square alpha over cos square alpha is tan square alpha. Okay, that means minus 1.25 equals 20 tan alpha minus 100 tan square alpha. So we have got a quadratic in tan alpha now. Let's bring everything to one side to solve it. 100 tan square alpha minus 20 tan alpha minus 1.25 equal to 0. Looking at this equation, it doesn't seem to be easily factorized. Therefore, let's use the quadratic formula for factorizing this. So therefore, a is equal to 100, b is equal to minus 20, and c is equal to minus 1.25. Putting them into our quadratic formula, we have tan alpha is equal to plus 20 plus or minus square root of 20 square minus 4 times 100 times minus 1.25. Okay, all over 2 times 100 is 200. Okay, now that means tan alpha is equal to 20 plus or minus 400 minus times minus will become plus 400 times 1.25 all over 200. Putting this into the calculator, we get tan alpha is equal to 1/4 or minus 1 over 20. Therefore, alpha is equal to arc tan 1/4 or arc tan minus 1 over 20. Putting this into the calculator, we get 14.04 degrees or minus 2.86 degrees, which is rejected. Therefore, alpha is equal to 14.04. Part C. State one limitation of the model that could affect your answer to Part B. We could say a few limitations, but just one is enough for us. So the most acceptable one is that the ball may have size and shape. Hence, will have spin effect. Also, air resistance could be there. These are not considered in the model. So this could affect the answer for Part B. Last part of the question. Find the time taken for the ball to travel from A to T. In Part B, we have got an equation for T, 20 over u cos alpha. We know alpha, but we don't know u yet. But there is another equation here. U equals square root of 2g over sine square alpha. Therefore, we can use u from here and alpha from what we calculated earlier to find out the value of t. So let's write t is equal to 20 over u cos alpha. And then u square is equal to 2g over sine square alpha. And also alpha is equal to 14.04 degrees. Putting these together, t equals 20 over u, which is square root of 2g over sine square alpha times cos alpha, which can be simplified further, 20 over, let's write this as square root of 2 times 9.8, okay, times cos 14.04 divided by sine square alpha square rooted will become sine 14.04. Putting them into the calculator, we get 1.13 seconds. That is the time taken for the ball to reach the target. Well, that's the end of the paper. Hope this was quite useful to you and that you enjoyed it. This paper contains some pretty good questions on hypothesis testing using sample mean under normal distribution, and in mechanics, good questions on projectiles as well as moment. After going through this walkthrough, I would strongly recommend you to do the paper on your own, setting the clock for the starting time and finishing time, and check for yourself your level of understanding as well as ability to finish within the time. If you need any further clarification on any of the questions, please feel free to post your comment under the video and I shall respond to it. Best wishes and till the next walkthrough. Bye.